topics, the key topics which we have finished, and I hope you all have gone through the assignments part also at the same time. And with this understanding that you know about random errors, you know about its behavior, you know about the nature of the random errors. That means it is not deterministic; it is stochastic in nature. Okay. Then obviously the error propagation concept, and you have solved a couple of problems also. Now our job now is to see, we cannot avoid random errors that will always be there when you collect the data, but now our job is to take care of that errors while performing your model or running certain model to estimate the unknowns, isn't it? So that was the basic concept. Having said that, we need to first understand, okay, where we are moving ahead. Whenever we are in this domain of so-called geoinformatics, what is our general approach? Because you will be having instrument, you will be having certain questions to answer. There will be some client that would come up to you with certain project, some certain problem. So how a general approach should be there, because that is very very important part. And uh, if you do not have the understanding for moving ahead with the certain methodology, then it will create certain problem while solving any critical case. Okay. So our job now is to, in this objective, our job is to now understand the overall methodology, and obviously whenever a problem will come, you will collect the data in order to solve that problem, and that will lead to the observations in the field, will lead to formation of a model or set of linear equations which we are going to solve. Okay. Just like in your basic case of area estimation with the help of length and width which you have collected in the field, you just have to form the model, and then you have to form the set of linear equations. Okay. So these are the two objectives of this lecture which we are going to discuss today, and mainly we'll focus, starting part will be on methodology in geoinformatics analysis. Okay. So I hope with this we can move ahead. So first is identify parameters and their precision. This is the first step. So the first step talks about whenever you read any problem, okay, any problem, you read the problem very carefully and identify the parameters. The parameters, what you need to estimate, what you need to find out, or in your problem statement, what are the estimation required for a particular parameter. Okay. And obviously we are not only interested in the parameters final value or the so called output value. Instead we are more interested in the how much, with what, how much precision we are achieving it. So that means if I say x is your final deliverable, okay, if I say x is your final output, so we are interested in not only the mu x but also the sigma x square. This is our job. Okay. So if x is your variable or parameter that you need to estimate or you need to find out, we are mainly interested in the mu x and its associated precision. Okay. So that is we are just talking about in this case of identify parameters and their precision. So unknown parameters or quantities of interest are identified along with their required precision. Okay. Achieved on a basis of an intimate knowledge of the project. There is no preset way of doing. That means you cannot simply say that for everything you have to follow the book. No. Something, the moment somebody reads the problem, you immediately, in your back of your mind, you immediately thought about what type of model is going to be applied, where, what type of observation we need to collect from the field, and what would be the parameters. So automatically it would come to your mind that this would be parameters that would need to be estimated. Sometimes those parameters would lead you to solve the problem by using those final deliverables to estimate certain another thing. Maybe that would be required on a certain case to case basis. Sometimes estimation of parameters only will solve the problem, but sometimes those parameters would again go a step further to solve your final deliverable. Okay, so that is the first case. So for any problem in the case, that's an in general methodology is there. Even today I am approaching to solve any problem, any research problem of the students with the looking for those steps, just these critical steps, so that whenever we discuss any problem, we should be very much sure what we are going to estimate. Okay, so identify the parameters and their precision. That's very important. Second is set up the mathematical model. Now, once you know that this is your observation which you have collected, these are your parameters which you have to estimate, you have to link these with a function model. Okay, this is what our objective is, because you cannot simply every time talks about that okay, this is the model, this is the equation which you just have to properly form it. Okay, so because the unknown parameters generally cannot be measured directly, it is necessary to formulate the function that relate them to the quantities that can be measured, the observable. Okay, that means you have to find out how these two domains, one is, or in mathematics we call it the space, the parameter space as well as the observation space or observable space. We have to form, or we have to link these two spaces with a model space. So these are the three space which we have to take care of. One is observable space, another is uh, parameter space, and you have to link them with a model space. So it's very critical way of looking at it, what we are going ahead. Okay, so formulate mathematical model to get unknown parameters in terms of quantities that can be measured, which is observable. Now you need to understand this part very carefully, that in geoinformatics, the first step is the functional model. The mathematical model is of two types. One is of functional model and another is stochastic model. It's very a very particular way of understanding. The mathematical model which we are talk about is that once you know the functional model, the moment you have written the functional model, that means once you have formed the model space, immediately immediately means without any second thought, you have to form the stochastic space or a stochastic model, how the errors would behave in the parameters. So these two models you have to prepare immediately. So from here onwards, we are not only talking about the functional space only. Instead, we are more interested also in parallel to stochastic space. What do you mean by stochastic? Because some of you may not be understanding it properly. The stochastic space is nothing but where we talk about the error behavior of the final deliverable. So let's say if you have estimated the area using length and width, which is your so-called primary observable. These are your observable. This is your parameter, and you have linked it with the mathematical model. Now, the next step is what is the error? If you know the stochastic model, your job is done. Now you do not need to worry about anything. You have solved the problem with mathematical model, as well as you have informed the client about the behavior of error in the final deliverable. That is your complete job. Okay. So this is the two step again. First is identify the parameters, identify their precision, what is required. Just quickly go back to your previous lecture before mid-semester break. We were discussing about the pre-analysis, where many of you would solve the problem that we want the height of that column to be estimated with this much precision, 0.005 meter. So this is the final precision that is being given, isn't it? And based on that final precision, required precision, you immediately uh, given the indication that how much precision would be required in in the three quantities that you need to estimate, which is sigma s, sigma t, sigma t, and whether you are capable as um, as a client, as a manufacturer, or as a consultant to provide that, or you have that instrumentation which can provide a desired sigma s, sigma t, sigma t. Similarly here, once you identify the parameters and you know what is the final precision required, immediately in your back of your mind you think of whether I'm capable of doing it, or I'm capable of achieving it or not. That's the pre-analysis. And the setup of a mathematical model, because in back of your mind you immediately thought about, okay, you want the height of that particular thing with the help of instrumentation or with the help of something. So immediately in back of your mind the model comes up, and in parallel to that model you talk about the stochastic model. Okay, these are the first two steps. Any questions so far? Okay, coming back to the third step, which is the design of pre-analysis or design of survey or pre-analysis, which we have done in fact, isn't it? uh, um, in the previous classes we have done the balancing of accuracies. So this third segment we have already covered, so no need to discuss this. We know that final deliverable was h, sigma h was given, it was known. We have done the backward processing and we have estimated what requirement would be there for initial observation and whether our instrumentation are capable or not. So that we have done. So this back analysis is there. Those who have not attended it, they can download the video from last class and they can quickly see it. There is very easy going approach is there. There were two approaches. One is case of balanced accuracies and case of imbalanced accuracy. That means you are not defining uh, uh, all component of the mathematical model as equal error contribution. Okay, so I think this is covered. Any questions in there you can ask me right now. There's no problem. If you have any doubts before moving ahead, it is your job to look at whether you are able to get it or not. Everybody should be very much careful that these steps are very small steps, but if you are not comfortable with understanding, that there is no point in moving forward. If you have any query, you can simply ask.
Sir,
Yes, Alok.
sir, if the precision of any parameters comes to infinity, what does it mean?
Sorry, say again.
Sir, if the precision of any parameter comes to infinity, what does it mean?
Infinity. How come it? What do you want to say? Infinity. What do you mean by saying infinity?
Uh, Sir, we can refer to exercise question number 7.3.
In which one?
So 7.3,
The
previous assignment.
what it is talking about?
Uh,
Just read the question.
so 1 minute. Mikhail and Gracie. Okay, 186. Sir, this question.
I'm not able to see it. Is it visible at your end?
Uh,
Yes, sir, it's visible.
Can you read it? Because I'm not able to see it.
Sir, in this question, area function is given.
Hmm.
So then it is determine the standard deviation with b alpha and beta. मतलब
Hmm.
पैरामीटर जो दे रखे हैं उनका स्टैंडर्ड डेविएशन निकालना है। फिर
Hmm.
और एरिया का स्टैंडर्ड डेविएशन दे रखा है 1 मीटर स्क्वायर।
ठीक है।
उसके बाद बोल रहा है एक्सप्लेन द अनयूजुअल रिजल्ट ऑब्टेन्ड फ्रॉम सिग्मा अल्फा। सर जो
हम्म।
सिग्मा अल्फा है 0 आ जा रहा है, तो उसकी वजह से फिर वो इंफिनिटी आ जा रहा है ना,
सिग्मा अल्फा
मतलब
सिग्मा अल्फा
नहीं,
0 आ जा रहा है।
नहीं सर, ये इंफिनिटी आएगा और डेल ए बाई डेल अल्फा करेंगे तो वो 0 आ रहा है। तो वही पूछ रहा है कि मतलब अनयूजुअल रिजल्ट ऑब्टेन
अच्छा,
फ्रॉम सिग्मा अल्फा।
तो नहीं, सिग्मा अल्फा का जो रिजल्ट आया है वो क्या आया है, वो मैं जानना चाह रहा हूँ। 1/0 करके आ रहा था क्या?
हाँ सर।
मतलब फाइनल वैल्यू 1/0 विच इज इक्वल टू इन्फिनिटी, ऐसा करके आ रहा है।
यस सर।
हाँ, तो ये मतलब आपसे ये पूछा जा रहा है इसमें कि इज इट अचीवेबल और नॉट। I
ओके
mean,
सर।
see, their precision is something which is related to instrument capabilities, isn't it? Precision is something which is a component or function of too many things. If a equipment is very costly, but the user is someone who cannot handle the instrument properly, or he is not capable of dealing with the instrument, you cannot achieve the maximum precision associated with that instrument. So similarly, the problem which converts to infinity, as you said. So I mean, when the question is asked, what do you say about unusual behavior? The unusual behavior is about you have to talk about the capabilities of achieving that much precision. Is it possible or not? Isn't it?
यस सर।
Hmm. तो अगर जीरो आ रहा है तो क्या पॉसिबिलिटी है, इन्फिनिटी आ रहा है तो क्या पॉसिबिलिटी, तो क्या इन्फिनिटी वाले को आप अचीव कर पाएंगे? मतलब ये तो ये कह रहा होगा कि अल्फा पे कोई मतलब ही नहीं कर रहा है, अल्फा कितना भी हो। इन्फिनिटी तो पॉजिटिव इन्फिनिटी तो मतलब लार्जर साइड की ओर जा रहा है ना। बताइए
यस सर।
भाई, इन्फिनिटी का मतलब क्या हुआ, पॉजिटिव इन्फिनिटी का मतलब क्या हुआ, टुवर्ड्स द लार्जर एंड।
यस सर।
तो इसका मतलब है कि उसके अल्फा से उसका एस्टिमेशन में कोई फर्क नहीं पड़ रहा है, उसका कहने का मतलब ये।
ओके सर। सर इन नेक्स्ट पार्ट, हेलो सर, व्हाट इज प्रैक्टिकल वैल्यू टू असाइन सिग्मा अल्फा?
हम्म
दिस इज द नेक्स्ट पार्ट।
व्हाट इज द प्रैक्टिकल वैल्यू फॉर।
व्हाट इज प्रैक्टिकल वैल्यू टू असाइन सिग्मा अल्फा?
हाँ, तो प्रैक्टिकल वैल्यू बताइए क्या हो सकती है, किस टाइप के इक्विपमेंट की बात की गई है इसमें, कोई इक्विपमेंट बताया गया, किस टाइप के इक्विपमेंट से मेजरमेंट हुआ है?
7.1 डिफर कर रहे हैं। Side A of a triangle ABC completed independent measurement of the नो सर, कुछ मतलब
नहीं
कोई इसमें नहीं बताया हुआ है।
जनरली आप जो इक्विपमेंट के बेसिस पे आप एक वैल्यू डिसाइड कर सकते हैं। जैसे अगर आप थियोडोलाइट से मेजर कर रहे हैं, जो कि कन्वेंशनल इंस्ट्रूमेंट हुआ करते थे, तो आप एक सर्टेन 5 सेकेंड के प्रिसीजन की बात कर सकते थे। अगर आप टोटल स्टेशन से आजकल मेजर कर रहे हैं, तो टोटल स्टेशन आजकल 1 सेकेंड के भी आ रहे हैं, 3 सेकेंड्स के भी आ रहे हैं, जो कि उनका प्रिसीजन स्टैंडर्ड बताते हैं, तो आप उससे भी जा सकते हैं। तो मतलब ये प्रैक्टिकल वैल्यू जो है वो बेस्ड ऑन इंस्ट्रूमेंटेशन चॉइस आप चूज कर सकते हैं।
ओके सर, थैंक यू।
चलिए, तो अपने वापस डिस्कशन पे आते हैं। The third step which we have done. The fourth is, once you have finalized with the pre-analysis part, now the next step is data acquisition or measurement. Now, once you have accepted the offer to work on it, that means you know you are capable, your instruments are capable to achieve that much precision which is desired. Now you will go for data acquisition. That means you will go into the field and you collect the data. So having obviously collecting the data requires your office work, that you will design the survey, how you are approaching it, how your staff is going to operate it, because you are the one who would be leading this task. So your staff would help you. So you have to, as I mean, whenever we go into the on the field for any project work, we have a meeting in our office, so to discuss how to approach the individual days with different types of tasks. You have to collect GPS data, you have to perform the TLS laser scanning, then you have to work with the total station. So we all discuss step by step. So this design the survey task would come in the office, that you will discuss this part in office. Once it is finalized that who's going to take care of total station, who's going to take care of GPS or other devices, the measurements are made according to the specifications based on accuracy indicated in the pre-analysis. Then you would take the you do the individual measurements, and observations are accessed for what? Observation are accessed for based on detecting the outliers, whether you are not having any outliers or not. That means the data set would be assessed or screened to find out whether or not they meet the prescribed accuracy. That means any blunder is not there, and if something goes wrong, you again re-measure the data. So that is part of measurements. Then pre-processing, obviously the no blunders at present, data is of desired quality, you all ensure that. One tries to find out the correct way for to know the systematic error and elimination of blunders using statistical testing procedure. We'll discuss this procedure, although we know sigma mu plus minus we in fact we have discussed somewhere mu plus minus 4 sigma. Nowadays the threshold has improved. Previously it was mu plus minus 3.29 sigma, which was there to remove the outliers, but now it has improved to 4 mu plus minus 4 sigma. Whether we'll apply this threshold to get the values which is outside that domain would be considered as outliers and they would be removed. And if you know the system, and if you are working in harsh environment where your observation are subject to atmospheric correction, you generally apply those models which you think that should be the case to apply any systematic error, known systematic error. So that would take care of the processing part. So please remember, if you just try to see here, that you are not talking about the so-called random errors. We are not talking about here the random error. Instead, only systematic error and blunders. We are only talking about the two, because we know the third one, which is random error, cannot be determined, cannot be removed. Only we have the stochastic characteristic of that random error, which we need to take into account and move further. So that is the fifth step. The sixth step is, once you know that your data is free from blunders, your data is free from any systematic errors, or any large systematic error, I would rather say. I would not say that any small systematic errors can also be handled. Sometimes it is missed, and it is part of the system. Later on, you will realize that there are certain statistical analysis or tools which would help you to remove those small systematic errors that goes undetected initially. Okay, so into going to the sixth step, where we obtain the solution or we perform the adjustment. Now, there are the two words which is written. One is solution and another is adjustment. What are the difference between these two? Can anybody just guess what do you mean by these two? Because obviously obtain solution is very straightforward approach, because in the first step you have identified the parameters. So obviously the solution is, obtain the solution means obtaining the values to those parameters which you have decided in the first step. But what do you mean by adjustment? Can anybody tell us? Anyone who could attempt? Solution is very clear, but what about the adjustment? Why this adjustment word is coming? Because this is the step where you would realize that why we are reading this subject.
So the sigma value we
Yes.
have obtained, we
Sorry.
add or the sigma value we have obtained, we add or subtract in the given height or something to adjust it to proper value.
No. No. Attempt once more. वैली शेट्टी बताएं.
Sir,
Hmm.
sir, whenever we had any redundant data inconsistency, we adjust the unique values to get the outcome for the unknown parameters. That means indirectly we can say adjustment is a process where we try to obtain a unique value for the unknown parameters using
The
some
definition,
methods.
yeah, definition seems correct, but it's still not very much clear that, see, we are obtaining solution, isn't it?
Yes,
But
sir.
where we are applying adjustment? You are right. You are saying that adopting certain methodologies or any approach to get a unique value for the solution. That's true. That's very much true. But that approach that is giving us the unique solution can be justified by only simply saying obtaining solution. Okay. What do you mean by adjustment? And what is the core component of the adjustment? Hmm. बताइए. Valley?
Sir.
Yes. बताइए.
So for the outcome, we will have some idea of our estimated value. So if we miss that any small variation for the from the expected value, we may adjust the values by using some methods.
Mm-hmm. You are deviating from your original definition. Anyone else? Alok?
Sir, in adjustment, if we alter some parameters in our solution, then we can achieve a value.
Chaliye रहने दीजिए. I'll explain it. See, from the first step onwards, we know that we have to do a mapping between observation space to your functional space, isn't it? That's what we have given you in this particular figure, that you have to map the observation space to parameter space with the help of a model space. Okay, and there are two things which you need to understand. You are using observables. Observables means the observation which itself are variables. That means they have the errors. What you are doing knowingly, that you are using those erroneous observation to estimate something. Now if you uh, talk about this to some layman or any mathematician, you would say you are using erroneous data to estimate something which would itself be erroneous, isn't it? So you know that your observation contains error, but having known that, again you are moving ahead and estimating the parameter. So parameter estimation could be achieved by any means, there is no problem. But what will you do to those erroneous observables, which this is the strongest part of your component? So reason is the name adjustment suggests that in the adjustment you are not only finding the values or estimating the parameter, you are also reducing the errors in your observables. So this adjustment part is something where you are doing both, and this adjustment is primarily referring this part, that means adjusting the observables. So that's why this name adjustment is coming here. Adjustment in a broad sense is a methodology where you are achieving the unique solution. That's true. That means the definition is, by definition, is true, but it is not only that. Another thing is you are reducing, or so-called effort is to remove all possible random errors in your observation. Although it is not possible to remove all those errors, that's why I have chosen the word reducing, because you are reducing those errors so that unique solution could be achieved in the case of adjustment. So that is the, are you getting it? Is it okay now?
Yes, sir.
Yes. Please remember that in your uh, in your adjustment part, our our job is not only to achieve the estimation, achieve the parameters value. Our job is to also look after the observables, because they are the backbone of system. If they are not there, you cannot achieve anything. And if they are erroneous, you will achieve erroneous estimation of the parameter. So that's the point of the adjustment. So I hope it is clear. Many a times a student get confused with the term adjustment. So why we are doing the adjustment? And that is the foundation of this course. That means we are trying to adjust the data set such that our our final aim to estimate the parameters could be achieved. So that is the sixth step. Now the seventh step is assessment of the results. So now everybody is achieved mu x, everybody is achieved sigma square x square. Now our job is to assess this result. So let's say I'm just again redrawing this. So you were having this uh, observables, let's say L, mu L, a vector, and sigma LL, the variance covariance matrix. And from this, you have achieved so-called mu x and sigma x square. It may be vector also, a single variables. So, sorry, if it is, let's say, it is also a matrix, a vector, sigma xx. So now your job is to assess the result as well as do the post analysis to get a green flag. Sometimes in a software you would see such type of flag with the result. So the result should have a green flag. Who would tell us? The post analysis part would tell us whether you could achieve you have achieved the required number of required precision or not. So our ultimate job of the post analysis is to judge the overall acceptability of the solution against the established standards. So standard could be anything, but you have to statistically prove that you have achieved the desired outcome. Assessment of results by performing array of array means not only one or two but array of statistical tests to that would be called as part of post analysis. Then assessment of the mathematical model for completeness together with a further assessment of observation for correctness. Then involves assessment of the computed unknown parameters and an examination of their capabilities with other independent determination of the same parameter. Should these exist? So we are trying to use those post analysis to have a balance and checks in our system so that no such result would go ahead that has failed these tests. And then the last step is the presentation of the result. A result are displayed and represented with this report from post analysis segment. So it is a multiple page report once you do the assessment. Although about the post analysis part, there are 2-3 popular distribution that we are going to explain at the later end of the course, how the post analysis is really being done. But at this time, you just quickly understand that there are chi-square test, then there is a t-test, and then there is a f-test. These are the 3 tests which we are going to apply on the achieved solution so that these tests will indicate whether it is sufficient to present your result to the client or not, or in indirect manner, have you received any green flag to your results or not. So that's the the necessity of using the post analysis. It is equally important because you are working on a real time project, real world project, where it is eventually required that your result should have gone through the robust analysis. That means nobody can question it later on because it involves money, manpower, time, and everything. So that is the one task. So these are the 8 steps, the final 8 steps of the so-called Geo-Informatics methodology. Again, quickly, just revisiting, identify parameters and their precision, set up mathematical model, perform the pre-analysis. Then once you finalize that, yes, we are okay to go ahead, you take the measurements, you take the data acquisitions, you do the pre-processing, you obtain the solution of adjustment, and you assess the results and present it. So that's the overall methodology. This is the one a big flow chart is presented of these same methodology. You can read it one by one. So begin by identify of parameters, then formulate mathematical model, then design the pre-analysis, the data acquisition. If data acquisition is okay, that's, I mean, you are good to go, final. If it is no, then you question it every time whether the correct data acquisition procedure is adopted. Okay, I mean, you can ask the question is whether you have achieved it not. So based on that, you will ask data acquisition okay, no, compute correct the data acquisition, yes, design okay, no, correct the design, no, design is also okay, then mathematical okay, no, correct the mathematical, or yes, then again correct the parameters. So that means the correct the parameters, this means initially you have must have x k plus 1, that means iteratively you will solve x k plus delta x, sorry. Is everything is right, then you can update your parameters. Okay, that is the one thing. Similarly, the other one which is talking about the uh, in the sense of post processing assessment of result. Okay, yes, represent it, no, then you go back again in this channel. So it is all about how to approach the problem, where you will see that the sufficient or desired result is not achieved by you, then there must be some problem with the steps. So how to go back and check at every stages. So your data acquisition must be some problem, your design would be there to be, rechecked. The mathematical model is to be, sometimes you forgot to add certain parameters in that model, or your model is not robust to accommodate all kind of problems. Sometimes what happened, just Vali Shetty told one case that you have redundant number of observations. So redundancy means, that means let's say you have to find out x. Okay, let me just again, let's say you have to find out the x, and that x could be estimated by only three observation, L1, L2, L3, but instead you have L4, L5 and L6 kind extra observation. So sometimes what happened, these are well precise, they are less precise, you will get poor result. So we have to devise such a system where all possible observation would come to the part of the model, and then you achieve the solution. We'll discuss that by one example. Just wait and watch. So what we are taking one example. Now before solving this example, I ask you to attempt it. Now, problem is very simple. Okay, just let me just open one problem. See, let's say there is a big rock is there. Okay, there is a big rock is there, and there are 2 points outside opposite to this rock. You cannot see from A to B or B to A. What I want is to have an estimate of the distance between A and B, approximate distance between A B. How would you approach it? Just like your problem of inaccessible point problem in the error propagation, here also you are given one task, that this is a big rock means you must have seen rocks, the big rocks where from one end to another end is not possible to see or visualize anything. So one task is given to estimate the distance between 2 points A and B. How would you do it? Attempt it. बताइए भाई शुभम।
Yes, sir.
बताइए कैसे करेंगे?
Yeah, if we consider a point C somewhere,
कैसे?
instrument we can measure the distance.
कहाँ से
Point
डिस्टेंस
is
मेजर? थोड़ा स्पीड, थोड़ा तेज बोलिए, आवाज नहीं आ रही आपकी। थोड़ा स्पीड, आपकी आवाज बहुत स्लो आ रही है।
from A point to
फ्रॉम
C,
ए
and
पॉइंट क्या करेंगे?
from A to C we can measure distance, and C to B.
ए टू बी एंड बी टू सी, तो सी कहाँ पर होगा?
C, so anywhere which is visible. Rock, in middle we have rock, side of the rock or any side which is visible, both A and B.
Okay, let's say this is the point C, this is visible, this is visible.
So,
Okay, then what?
and now we can measure angle ACB.
ए सी बी ये मेजर कर लिया, और
Now we can use sine rule to find AB.
नहीं, तो एक एक एंगल से कैसे मेजर हो जाएगा साइन रूल?
Sir, we can use cosine rule. From cosine rule, from that we can measure.
नहीं, तो उसको साइन रूल क्यों नहीं लगेगा, ये तो बताइए।
In that we need two angle.
तो एंगल नहीं है आपके पास? जब आप एक एंगल मेजर कर सकते हैं तो ये भी मेजर कर सकते हैं, ये क्यों नहीं मेजर हो सकता?
So from cosine we can find easily if we know one angle and.
तो वही तो मैं कह रहा हूँ, आपने आपके पास पहले आप टोटल ऑब्जर्वेशन तो बताइए। हाउ मेनी ऑब्जर्वेशंस यू हैव विद यू?
Two side and one angle.
Two side and one angle.
angle.
But no, you have three angles. Alpha 1, alpha 2, alpha 3. You have three angles and two sides. Three angles, two side.
Okay. Then in that case we can use both.
हाँ, तो उसको पूरा बताइए। आप 8वीं क्लास वाले बच्चे की तरह क्यों बात कर रहे हैं कि ये भी हो सकता हो? आप पूरा बताइए, तो इलेबोरेट करिए, कितने केस बनेंगे? हाउ मेनी पॉसिबल केसेस?
So how many to find AB?
Yes, obviously, और क्या क्वेश्चन वही है।
So we will have two cases.
Only two case?
Yes, sir.
Sure?
Yes, sir.
गलत। Not two cases. There would be राहुल, आप अटेम्प्ट करिए।
यस सर।
बताइए।
Sir, I think 2 cases only.
बताइए, 2 नो केस बताइए। पहला केस बताइए।
सर एक में जैसे कि 3 एंगल हैं और 2 साइड हैं जो सर है, और एक सर एक कॉस रूल से जो सर शुभम ने बताया सर ऐसा।
बताओ कॉस रूल क्या होता है, बताओ। कॉस क्या लिखे हैं?
कॉस
वो सब हवा में पढ़ के आया है, बीटेक ईटेक हवा में करके आया हो ना। साइन रूल कॉस रूल आपको नहीं आ रहा है। दूसरा क्या है केस?
दूसरा ही साइन का सर, साइड अपॉन
क्या है?
एंगल सर साइन।
बताओ बताओ कैसे लिखे हैं, हमें नहीं
सर
आते
एक
लिखना, बताओ।
सर जैसे कि ए सी साइन बी इक्वल टू अपोजिट साइड का सर एंगल
साइन
सर जैसे ए सी अपॉन साइन अल्फा अल्फा 3 सर इक्वल टू ए बी अपॉन साइन अल्फा 2 और सर साइन अल्फा 1।
तो ये यही 2 केस की बात आप कर रहे हैं।
यस सर।
और कोई नहीं होगा, सोच लीजिए। क्यों भाई? शुभ राहुल,
यस सर।
और कोई नहीं होगा?
सर ये
क्यों? जब आपने AC अपॉन साइन अल्फा 3 इज इक्वल टू AB अपॉन साइन अल्फा 2 किया, तो तीसरा क्या बचा?
So we will have three
सर ये
equations.
हैं?
यस सर, BC अपॉन साइन अल्फा 1 सर बोला था।
तो ये
BC अपॉन
दूसरा
साइन,
हाँ, तो ये नहीं हो गया, ये तीसरा मेथड हो गया।
यस सर बताया था।
कहाँ बता रहे थे आप? तो 2 ही कह रहे थे। और
नहीं
कॉस
सर
रूल
बोल रहा
भी,
था बट सर
कॉस रूल भी 3 लगेंगे।
यस सर,
क्या
कॉस
ये
ए
सर
कॉस बी हम आपसे।
है? तो फिर ऐसे कैसे, मतलब कैसे चला रहे हो तुम काम? आप लोग मतलब बिल्कुल हल्का फुल्का भी आप मैथमेटिक्स में नहीं आप बताना चाहेंगे, तो कैसे आगे जॉब करेंगे आप? हुँ? तो टोटल आपके 5 ऑब्जर्वेशन हैं, अल्फा 1 अल्फा 2 अल्फा 3। ये 2 साइड्स हैं, 3 एंगल 2 साइड्स। यू हैव टू थिंक ऑफ मेथड्स। तो एक तो है, पहला इक्वेशन जो आपकी है वो सिग्मा अल्फा इज इक्वल टू 180 डिग्री। बाकी 5 ये मेथड जो आपने खुद लिखे, 3 फ्रॉम कॉस रूल एंड 2 फ्रॉम साइन रूल। तो 6 तो मेथड हम ही ने आपको बता दिए जिससे आपके सोल्यूशन निकलेंगे। तो एडजस्टमेंट में यू नीड टू इंश्योर दैट नो सच वन केस शुड बी लेफ्ट आउट जहां से सोल्यूशन मिलने की संभावना है। उसका रीजन क्या है? सो दैट यू कुड चेक लेटर ऑन अबाउट द कंसिस्टेंसी ऑफ योर सोल्यूशन। अभी यहां से जो आंसर आ रहा है और यहां से जो आंसर आ रहा है वो अलग अलग होंगे, बिकॉज ऑब्जर्वेशंस आर डिफरेंट, सिस्टम में इनपुट डिफरेंट है। तो ये ये नहीं कि मेरे फ्रेंड ने 2 बता दी तो मैं भी 2 ही बोलूंगा, चाहे जो हो जाए, आर या पार। आपको अपने विवेक का इस्तेमाल करना है कि हमने क्या पढ़ा है अपने बैकग्राउंड में। तो अभी तक तो 2 ही थे, अब आप खुद ही बोलने लगे 5। तो इसका मतलब है कि आप लोग की एनालिटिकल स्किल्स बहुत पुअर हैं, उसको आपको इनहेंस करना है। चलिए, कमिंग बैक टू योर प्रॉब्लम, so we have to define the horizontal distance between 2 points AB. So what we have 3 angles which we call it as a horizontal angle and 2 distances D1 and D2. Then our job is to find the all possible mathematical model. हमेशा याद रखिए, you will never stop by only writing one model. You have to look for multiple model options so that consistency should be checked. अगर आपके मॉडल ही आपके नॉलेज में नहीं होंगे तो आप कंसिस्टेंसी कैसे चेक करेंगे? आप कर ही नहीं पाएंगे, आपको उसी को मानेंगे यही सही आया जो रिजल्ट 1 से आ गया। So you should be very careful about looking at those so-called mathematical models. Okay. Now, in the next slide, you will try to see those models which are written. So various elements of model must be related to each other by an appropriate set of mathematical equations, and we are writing the 6th equation. The first one is alpha 1 plus alpha 2 plus alpha 3 must be 180 degree. अब भाई आप A से B की ओर तो देख नहीं पा रहे, तो ये एंगल जब मेजर करेंगे तो उसमें मिस्टेक्स हो सकती है। आपको उस पॉसिबल अप्रोक्सीमेट अल्फा तक पहुंचना है जो कि इस एंगल को सेटिस्फाई कर रहा हो। You cannot see A to B, then how can you measure this angle? तो आप अप्रोक्सीमेट ही तो कर रहे होंगे कि अल्फा 1 और अल्फा 2 की वैल्यू ऐसी आए जो कि इस रिलेशन को सेटिस्फाई तो करे, तभी तो आप आगे बढ़ोगे। आर यू गेटिंग इट और नॉट? कोई कह सकता है ना कि सर इससे तो कहीं भी x नहीं आ रहा है, इससे तो इस इक्वेशन में तो कहीं पे भी x नहीं है, तो इससे कैसे सोल्यूशन मिलेगा? बट दिस इक्वेशन इज एक्चुअली इंश्योरिंग दैट यू कैन मूव अहेड। I hope you understand this point, because if you do not have the appropriate value of alpha 1 and alpha 2, which is approaching the summation of all internal angles is approaching 180 degree, you cannot start the problem. You cannot find out x, because obviously if your alpha is poor, alpha is wrong in fact, how can you ensure that your x would be right? X would automatically be incorrect. So that is one thing. Then obviously the sine rule, and obviously the cos rule, the 3 cos rules. Now, what is the important point which you need to understand? See, this is a very simple problem of class 9th level mathematics, but where it is getting critical, just understand this point. Now, not all 6 equations are needed to establish required functional relationship among the 6 element of the triangle. Any 3 would suffice. आप इस क्वेश्चन को देखिए, 1 2 3 आंसर, 1 2 3 आंसर, 1 2 3 आंसर। तो आप जो है इनफैक्ट आप जो है सोल्यूशन विद इन 3 ऑब्जर्वेशंस अचीव कर सकते हैं। फॉर एनी ट्रायंगल you need 3 parameter to define the shape and size. Obviously one must be distance. तो आप डिफाइन करेंगे one must be one of which must be distance are required to define the triangle, both size and shape. And mathematically you can use 1 2 or 3, or by 4 5 or 6, or any other suitable combination of these equation of 6. And there are clearly several ways to obtain the functional representation of mathematical model. This slide is actually presented to give you a hint that whenever you look at the problem, do not miss any of the functional relationship that could hold true for your case. You must ensure that you have written all possible functional relationship. Okay. Now our job is, now here the 11th or 9th or 10th level trigonometry ends. Now the GDP, where we are moving with this course, comes into the picture. Now if you take solve x from this, you will get a different x. You will solve from here, you will get a different x. Similarly, from all these, you will get a different x. You will never see a same x. That means x is inconsistency is there in your final value of x, and the reason is very simple. Your observations are erroneous. The data in d1 is having error, d2 is having error, alpha 1, alpha 2 and alpha 3, it is having error. They all are having error. That's why your final x is not coming as same. The objective should be to have a consistent x. Nobody would accept your result if you are 6 of you are coming with a different x, isn't it? The objective of adjustment, as in the discussion also, we achieved that there should be one x, the consistent x. So our job is to, you know, for a plane triangle in which 5 elements d1, d2, alpha 1, alpha 2, alpha 3 are observables, since distance can be computed from only 3 observable, the plane triangle is overdetermined. Overdetermined means the number of observations are larger than number of unknown. Number of observation is, which is represented by n, a number of observation, that is u, which is, there is a redundancy, which is n minus u. So all well designed survey projects should have redundancy built into them. A survey without redundancy is unprotected, unchecked, and very vulnerable. Redundancy, therefore, is a necessary ingredient of every professional executed survey. Variation and redundancy together create inconsistent, but we can handle it. If you do not have redundancy, you cannot have a balance and checks in your system. You must have redundancy. आप एग्जाम में जब जाते हैं, whenever you go to write for any exam, be it your 12th level or be it in your BTech level, you never go with a single pen, isn't it? You always have a backup of pen. That is redundancy. You follow the redundancy in your daily life. That is what we are talking here. But redundancy should not create inconsistency. We have to form a mechanism or understand an approach through which we can get a consistent solution. That is our job. Okay. So let's say you have assigned those values to alpha 1, alpha 2, alpha 3 and the d1, d2. Now our job is to see how the inconsistency could be observed. See here, with there are, see, we have alpha 1, alpha 2, alpha 3, d1, d2. So we have 5 observation, and out of 5 we have to choose 3. One must be distance to get the x. So see, the combinations are presented here. There are total 9 combinations are there. Alpha 1, alpha 2, d1, alpha 1, alpha 3, d1, alpha 2, alpha 3, d1. Now here the case of d1 ends. Then again repeat it with d2, alpha 1, alpha 2, d2, alpha 1, alpha 3, d2, alpha 2, alpha 3, d2 ends. Now two distances together, alpha 1, d1, d2, alpha 2, d1, d2, alpha 3, d1, d2. So there are total 9 such cases. You have the values of L, alpha 1, alpha 2, alpha 3, d1, d2. You get the x, but it is very inconsistent. First x is from first combination 725.651. Then 665, then 671, 670, 691, 684, 0.612, 0.714, 0.677. All 9 are different. This is the classic case of adjustment. Why your data needs adjustment? Because if you are an engineer, a geospatial professional, you cannot move ahead from here onwards until you achieve a single X. This is the criticality which we need to understand, that we need to remove first. So different combination of input observable lead to different solution. In other words, there is a inconsistency. So adjustment, in the case of adjustment, you only go for adjustment if there is a inconsistency. If there is no inconsistency, that means your data is free from error, or you are working in ideal environment. That's not always the case. Okay, just look at this table, and if you want to ask anything, just ask, because after this we'll move ahead and we try to develop methodology for different approaches. Because as I've told you, and in fact one of the student also reminded, that you need to look for those approach to get a consistent solution. Just look at this table. If anything wrong is there, you could suggest me, but what you need to understand is, simply having the alpha 1, alpha 2, alpha 3, d1, d2, that job is not end. You have to devise and hand over a simple X, a consistent X. That is your job. अगर आप client को you forward this table, he would be so much confused that he said, okay, which X to go ahead for? What you would tell him? As a geospatial professional, now I'm going to ask you that how and what X you would be suggesting him to choose. Any guesses? Alok, बताइए.
सर ये जितने रिजल्ट आए सबका मीन ले लेंगे.
Again, my suggestion is always do not jump to simply one thing which you know from your past few years. Just think very intelligently, and then suggest me multiple answers, not one. Just look at the problem. First you look at the problem. A problem is very simple. Basic theory says you should have redundancy, but the practicality says you would have inconsistency. Now here in this case we had redundancy, but we have inconsistency in final solution. So averaging is always an easy-going task, isn't it? You cannot exclude averaging, but will it serve the purpose? Is there any other option? Let me tell you also very frankly. Let's say alpha 1, alpha 2 and d2 is measured by a very good professional, very good staff, whom you can proud of or rely on. But alpha 3 and d1 is measured by a newly recruited staff whose performance you have not evaluated, you have just given him job. What will happen in terms of average? You are mixing the good quality observation with bad quality observation. You are committing another error. Then what will you do? Have you thought of it?
So we can provide weight to according to surveyor's experience.
So again, you would be giving much larger weight to this. But when you are averaging, you are averaging with the poor weights. Why would you do it? If you know alpha 1, alpha 2 and D2 is very best, then you would never go for averaging. You will simply say alpha 1, alpha 2 and D2. That means fourth is best out of 9. You know it. Then why would you go for averaging? Averaging would never give you the fourth solution 0.6701. It would always be on higher side because rest our values are quite much higher. Averaging is done when you ensure that everything is equal. Now, if consistency is there, there must be some reason due to random errors. Let's say just average it out. But now you know that the certain set of observation is very much precise, way beyond the control of the other group. Why would you go for average? That is blunder you are making. So it is essential that inconsistency be removed. That means it implies that the observation must be altered to fit. See this word. Observations must be altered. This is what I was telling when I was discussing about adjustment. This is adjustment, the integral part of adjustment. That it implies that the observations must be altered. That's true, because your observation contains the errors and they must be altered. There must be certain corrections that must be applied to those observations before moving ahead to fit the model exactly. Now let me tell you once again. Let's say alpha 1 plus alpha 2 plus alpha 3 is not equal to 180-degree. And that's the perfectly true, because in no way you can achieve a perfect 180-degree in real world. You will always have certain misclosure in the internal angles. And how you are going to remove it? Again, just from your basic 11th level mind, you simply say, sir, whatever the misclosure is there, let's say 3-second misclosure is there, we will divide it by 3 and will provide correction of 1 second to each angle. That's what you will say if I ask you the question. Okay, but not every time this is the case. I will discuss certain cases where you will see different values of misclosures would be given. Obviously, if you assign weights, the value of 1 second could not be applied to all. There must be some different values would be applied based on the weights. That's true. So implies that the observation must be altered to fit the mathematical model exactly, thereby agreeing with each other and producing solution for the model that is consistent. Second is observations that are consistent lead to the same value for every computed parameter regardless of the root. That means if you have such a system, that means from wherever you go, whether you go from first, second, third, eighth, you will get a single value of x, not 9 values. You will get a single value of x. That is our job. Elimination of inconsistency is accomplished through the computational process known as adjustment. This is the definition which I wanted to give you at this point. The elimination of the inconsistency is accomplished through the computational process. This computational process involves altering the observations also. You get my point? Elimination of inconsistency is accomplished through the computational process known as adjustment. This is the final definition of it, and you have seen from your eyes only that this is a very different case that you have came across up till now. Previously you were a little more careless in working with mathematical models. You simply work with mathematical models just like you are believing everything is fine and okay. You can simply go ahead, but it is not the case here onwards. Every observation you have to look as a point of view of the detective. Just like detective try to figure it out who is the main accused or something like that, you have to figure it out. What are the sources of errors, what are the types of errors, the nature of errors, magnitude of errors, what are the models. You have to think of everything. Then only you would be a good geoinformatics professional. Okay, what are the alternatives? The alternatives are fix the best. These are the I mean from your side only you you are suggested these two solutions. One is fix the best, adjust the rest. Now you know that alpha 1, alpha 2 and D2 are the best. Alpha 1, alpha and alpha 3 and D1 are not good. So you fix the best, then you adjust the rest. Compute all possible combinations and average. That's true. That is one way. One of the solution is given by one student that you could go ahead and take the average. Third one is adjust in simple independent step that we'll discuss. And fourth one is adjust in accordance with a specified criteria. Still redundancy is there in the solution, isn't it? Even also on adjustment itself is providing redundancy. Which way to go? Obviously every way has certain limitations and certain advantages, but you have to be biased, then only you will choose one. So you have to choose one which is mathematically proven. You are not biased, and it is best among all. This is our job. Now our job is to get unbiased, best, and is as in our first slide I've told you, linearized mathematical model. That means it should be linear, because we have, if it is non-linear, we have to use Taylor series expansion. We have to linearize it. Estimate. So you have to choose a model which is best, unbiased, linear estimate. That is providing, sorry, you have to choose that model which is providing estimate which would be best, unbiased, linear estimate, which is in short we call it blue. This is our job. So not only from observation point of view you had the combination, from adjustment point of view also you had various combination. Now this is very trickiest part. You cannot take one to one. Let us discuss first case. Fix the best, adjust the rest. What is the drawback? Best observation just enough for a solution are selected and held fixed, and all other observation are adjusted to agree with the fixed value. Model parameters are also computed from the fixed values. For example, D1, D2 and alpha 3 are selected as the best observation, perhaps on the basis of condition under which they are measured were very favorable, or the staff is well equipped or well trained to work with high sophisticated instrument are held fixed. Distance x, n angles alpha 1 and alpha 2 are then computed from d1, d2, alpha 3 using certain equations and respectively. The decision on what observation are best may have a rational basis under certain conditions. However, generally it is arbitrary, and this method is not recommended. So that's true. I mean, anything which doesn't have a mathematical basis, you cannot go ahead with it. Just by the staff is well trained or favorable condition is there, you cannot choose something is best. You have to prove it. The second one is compute all possible combinations and average. Again, I'm not reading it this all, you can read it out. I'm just telling you the combination with the poor quality data and higher quality data would increase the quality of poor data set and decrease the quality of good quality data set, but it is not recommended since you do not know about the weights, let's say. Okay, so you can read this. Not it is a good to go approach, but it's not efficient procedure because so many solutions have to be computed. For this reason, this method is not recommended. Third one is adjust in simple independent steps. That means adjust the interior angles of the triangle equally so that their sum to be 180 degree. The satisfy equation 1 of the mathematical model. Step 2, compute parameter x from the adjusted angles and D2 observation and equation 3 and take an average. Step 3, compute adjusted values of D1 and D2 and from the adjusted angles and the average value for x using equation 2 and 3 respectively. So it means you are going from step 1 to 2 and 2 and to 3 just to make sure that you have the x from two different mechanisms. Relatively straightforward and used for simple problems such as praying triangle or traverse. Procedure becomes more difficult to apply and more questionable in effectiveness when used in more complicated survey problems. Therefore, not recommended for anything but relatively simple problem. For simple problem, you can move ahead. So summary is, if you method 1, if you apply method 1, which is fix the best and adjust the rest. So you have applied corrections wherever you found it necessary because you have fixed it d1, d2 and alpha 3 as best, so you will not apply any corrections. Hence, your correction would be applied to alpha 1 and alpha 2 and you will get this value. Method 2, adjustment values, that means adjusted correction, averaging phenomena, you apply corrections to all, you get this. Method 3rd, you apply in a step manner, independent step manner, and you provide the correction and you achieve it. So in this case, the value of 0.670, which I know previously that it was the best, is achieved, but it's not the perfect way because still it is not proven that it is recommended for in general case or not. So what you need to do, you need to go for 4th step. That means adjust in accordance with a specified criterion, that is mathematical criteria. What is the primary aim? Goals of adjustment: consistency, achieve the consistency. Second, observation to be disturbed as little as possible by adjustment, implies smallness of adjustment correction. Third one is impose a specific minimizing criterion on the adjustment solution at the very beginning. Sum of magnitude of all the corrections to be minimized, adjustment correction with maximum magnitude to be minimized, and sum of squares of all the adjustment criteria to be minimized, that is least square. So first one is sum of all corrections to be minimized, max Vi to be minimized, and third one is sum of squares of the errors to be minimized. So the third one, which is proven and have mathematical so-called background to answer it, whether it is acceptable or not, it is mathematically proven that summation of squares of the residual, when it is going to be minimized, this is the criterion which is mathematically proven and provides the estimates which are blue in nature. That is best linear unbiased estimate. That is mathematically proven. Okay. So this ends with this conclusion that the three methods, although generally applied for a small problem, but since as a geoinformatics professionals, you have to work with a large cities, large states, sometimes you cannot go ahead with a small or easygoing problem. You have to think of a larger in general solutions. So for that, the solution from the least square criterion is acceptable. That means summation of squares of the residuals or errors, corrections to be minimized. Now you would be thinking, what is residual? Residual, I have told you, the Li minus L bar, or we have told the MPV value of L. The variation from individual observation to the MPV value or simply the mean value is known as the residual. We need to minimize. This is for the observation case. Please remember, you are choosing one adjustment method that is purely based on observations. Okay. Once you achieve this, obviously the corresponding X would be consistent. And that is the way you are achieving the consistent X. At the same time, you are adjusting the data set. So in general, I generally used to write like that. You have L, initially you have L and sigma LL, and you are moving from X sigma XX by you have the observable, the variance covariance matrix of the observable, and by minimizing or following the least square solution, you are achieving the X sigma XX plus L hat and sigma LL hat. That means you are achieving not only the X and sigma XX, but you are also achieving the adjusted value of observation and adjusted variance covariance matrix of observations. So that is our final aim with any kind of adjustment method. Any questions, please? You are free to ask, because it's very good time to ask the question. Any of your stupid questions also will be answered. Many a times what happens, people do not ask question, might be thinking, okay, probably everybody should know it, why should I ask? This is the high time you should ask the question. It is necessary, so that you should grasp the concept, because later on from the next class onward, what we'll do, we will engage you, and we will tell you the core concept, core methodological background that is based on least square principle that would be used in your domain. But this is necessary, because every time what happens, you should first create the necessity, then only you will be interested in reading the content. Or necessity is why we are reading the least square solution, because we know that there is an inconsistency if we move from 10 such combinations. We'll get the solution by small theoretical adjustment methods, but in general it is not applied. So that's why we are moving towards least square criterion. That is mathematically proven. In next class, I will show you the mathematical derivation of this, which you are given as a theory, that sigma v square, summation of v square, vi squares to be minimum. We will discuss the mathematical derivation, because it is important, because if you do not see the mathematical derivation, probably it would be little discouraging, because from your engineering background you should know the derivation. Although many of you could solve it, it would come from, I'm just writing or giving you hint from where it will come from. It will come from Gaussian law of accidental error slides. In the first lecture, where we have seen the Gaussian law of accidental errors, and we have seen certain probability distribution, it is coming from same equation. We will prove it out. Although in many of the books it is not there. The reason is very simple, because they simply say that least square criterion is well known. People can go and read the content from here and there, and they never highlight the derivation in many of the books. But it is very simple. I mean, you can derive it out anytime you want. Okay, any questions so far? यशोवर्धन,
यस सर।
आपको समझ में आया?
यस सर।
ओके, सुनील।
यस सर।
आपको समझ में आया आज का लेक्चर क्या पढ़ाया गया?
यस सर।
प्रवीण,
यस सर।
क्लास कर रहे हैं रेगुलर आप?
यस सर।
फॉलो कर रहे हैं कंटेंट जो पढ़ाया जा रहा है?
यस सर। सर इन प्रीवियस हेलो।
बोलिए
सर, जो प्रॉब्लम बताया गया सर, इसको हम क्या नाम क्लोज ट्रैवर्स से भी तो सॉल्व कर सकते हैं?
हाँ, यही चीज मैं आपसे कहना चाह रहा हूँ। एक स्पेसिफाइड मेथड पे नहीं जाना है कि पता चला आपने एक पढ़ लिया तो आप सोचेंगे कि दूसरी प्रॉब्लम आ गई तो कैसे करेंगे। एडजस्टमेंट हमेशा एक मेथड्स का नहीं होना चाहिए। एडजस्टमेंट मेथड ऐसा होना चाहिए, और ये हमारी ऐतिहासिक मिस्टेक है कि सिविल इंजीनियरिंग में केवल एक मेथड पढ़ा दिया जाता है और उसी पे हम लोग पूरा सिविल इंजीनियरिंग खत्म करते रहे। Probably this is the way you would be exercising your content, and possibly be prepared for a independent steps, so that you would forget about those steps which you have read in your BTech. This is the one of the best approach which other institution and across other universities are following in their UG curriculum. We are very, very much far behind from the world curriculum.
Yes, sir.
अरुण कुमार।
यस सर।
आपको समझ में आ रहा है?
यस सर, आ रहा है।
चलिए, तो पार्टिसिपेट किया करिए डिस्कशन में। एकदम कान बंद करके बैठ जाते हो तुम लोग, बोलते नहीं। कैसे समझ में आएगा? मालूम कैसे चलेगा तुम्हें समझ में आ रहा है?
सर बताते बट टर्न नहीं आ रहा था।
टर्न आने के लिए हाथ ऊंचा